Okay, we are live. Let's wait a couple of seconds until I get the audio feedback. Then I'm sure that everything works fine. But from here, seems okay. Latency is quite high, something around 30 seconds. And this time we will continue. Well, this time I have finally again some time to. Is the audio working? Audio is off. Audio is working. I did work on a few projects and now have time to continue on my USB hub project. And where we stopped last time, we had several issues on the downstream port. Well, not only on the downstream, regarding power. If we had the overcurrent sensor, which was drawing too much power from this tiny USB controller, and the USB hub did reset all the time when it was powered over USB and not when it was powered over one of these power inputs. This is what we'll first try. I think the issue of the reset is because of this fuse here. But we will see if this is the case actually with an oscilloscope. Let's try again if we can reproduce the error. That's a good start. How do we do it? We will try to connect up. I'll have a direct line from my computer to the USB hub, and I need to zoom a bit back out. I don't think you need the datasheet for now, so I'll close it and I'll open the DMM. Here. Okay, but I know what you do need is the tone control, so I can show you that it does reset. This, I'll put it here. This I can close and up. Now you can see my journal. And we'll see if it really resets all the time. So, up. USB cable is plugged to the port, and if I plug it in, normally it should reset. Yep. It does reset, and we see the blinking also of this red LED indicating the reset. I think it's a power reset, probably the fuse triggering. We will check this out immediately. I probably can't do it with the multimeter because it's not fast enough, but with the oscilloscope, so I need to start the oscilloscope though. Let's start the capture of the oscilloscope. Okay. And let's show the oscilloscope. It is capturing. Here we have a picture of the oscilloscope, and it should update it. So, let's grab a channel. We want ground. This pin 1 is ground. I try always to make pin 1 ground. And then I need the 5-volt input. I think we can also find it on one of these pins, because this will be the output for the 5-volt. Which pin is the 5-volt output? Here is a 5-volt, I think this one, but it's too close. This is probably 5-volt. Let's try also if it works better with the input directly from the power supply. Up. Let's connect the power supply. 1, 2, and you can normally also see the power supply. Let's set it to 500 milliamp. And if I switch it on, yep, that works. So let's switch it off. And if I plug power, 5-volt is this. I'll write it on this side. I don't want to turn it. This is 5-volt. This is 12 volt. Now I know it for the next time. I'll switch off this since we don't need it anymore. But I can put, shall I leave? Yeah, let's leave the thing right on there, shift 2, this one. I will move this one here, and I'll leave the schematic. So you can see what's happening or where I'm probing. This is 3.3 volt, right? Yeah, we don't have a 5 volt pin. I should put a 5 volt pin for debugging. I didn't think about that. Let me guess, if I guess it, so this is 1, 2, 3, 4, pin 4 of the buck converter. Is it 5 volts? Pin 4, yep, that's the feedback, so it is 5 volts, but I don't have a way to probe it really cleverly without shorting to anything else. Nah, I need another 5 volt point. Or I can solder a cable, a lead. Probably let's do that. Let's just solder a pin. Switch on the soldering iron. I won't have too much time today. Like something like 3 hours. 3 hours is fine. I hope I can at least figure out the bug in 3 hours. So soldering iron is getting warm. I need some cables. It's ground. It's not a. Here, this one. We will put it on pin 4 because it's readily accessible. It's huge. Are you warm enough? I don't think you heated up. No, not yet, but now you are. Power is switched off, so I can use the soldering iron. Theoretically, I should also remove the connector because both might not have the same potential. The earth potential, but I'm too lazy. Both meaning the board, or the power supply, which is connected to the board, and soldering iron, which is earth. So this I have to recrimp it. This one is far too loose. It's holding nothing. Let's recrimp it. It's getting annoying. Crimp. Where are my crimp? Header crimp. I might not have to recrimp it. I might have a second one. Yeah, I do have a second one. Maybe this one is not that loose. Let's check it out. It's a bit better. It's a bit longer, but we're not doing high speed signal. This, I know I need to recrimp it. Too loose. So here we have the oscilloscope. Now if I switch on, we should see on channel 1, which is yellow, we should see 5 volt. And we see 5 volts. It's just that the scale is huge. Okay. And surprisingly, we see 5 volts, but there is no power on the output. We should have power here. Maybe if there's no USB, there's no power. Let's check it out. It doesn't enable power if there's no USB. Might be the case. And it's only using 1 milliamp. I'm a bit surprised. Let's connect. Okay, the USB hub is there. Okay. And the green light is far too bright. But the power works. And yeah, so was it intended? If we remove USB, power still stays on. Let's reset. Now let's replug USB. Oh, wait. Let's switch it off. Let's switch it on. Okay. Why are you detecting a USB on the downstream? Red light means full speed. There's nothing on the downstream. Maybe it's in a debug mode. If I plug it in, then it doesn't switch on power. USB is not detected. Oh, what's this? This issue is new. Like here it seems it's on a debug mode. Okay, yeah, there's a tiny bit of red LED. It's in debug mode again. Why would it be in a debug mode and it's not enumerating? Why so many errors? Okay, now this is the pattern where it blinks all the time because it can start and it doesn't enumerate. And if I provide 5 volts, it should be able to enumerate and it switches on correctly. Okay, there's something which puts it in a debug mode. Last time we spent a lot of time figuring out why it was in a debug mode, and one of the issue was that the EEPROM value was there's one EEPROM field which wasn't documented, which actually puts it in debug mode, but in this case we removed it and it works fine here. This is weird. If I unplug and replug, it doesn't enumerate anymore. Oh no, it doesn't enumerate. Okay, so we can test 5 volts this way. Now let's see on the oscilloscope, and let's trigger in channel 1 menu, trigger edge on channel 1, and a falling edge, and we trigger at something at 2 volts. That seems fine. A bit higher so we can see the dip. Let's go at 4 volts. Normal mode. Okay, now it's waiting for the trigger. And if I remove power completely, the oscilloscope should trigger. Let's try it out. Remove power off. Yep, it does trigger. It's too fast, but it does trigger. Now let's try just with USB and see if it's actually, yep, there's a dip. And I think this fuse is triggering. Yeah, you clearly see the dip, and then it's resetting. This fuse should only trigger above 500 milliamp. I'm sure we are drawing more than 500 milliamp to charge all the capacitor. We have this capacitor and this capacitor to charge. I think one is 470, this one is 150, so we are around 600 microfarad, which is quite a lot. But I would need to measure how much current it draws. How do I do that? I do have several solutions. I could just put a resistor. No, I can't because it's over USB. Ah, but it doesn't have to be over this USB. It can be over any USB, meaning over this one would also work. Let's try it out. So let's see if it's still. Now it does nothing. Now it's stable. So it's not the fuse triggering. I should measure on the input. But then edge is on, but then it doesn't go on also. Ah, we know. Oh, we have 5 volts. Oh, I see it in the oscilloscope, but the hub doesn't enable power until it's enumerated. Is it this way? Here let's remove it. Now 0 volts. It goes down slowly because it needs to discharge the capacitors. Plug it in. It's on. Oh. Something happened to my USB power supply. That I've never seen that. What? This is just a USB charger. There should be nothing happening on this one. But it really started. I've never seen this happen. I have can I show it to you? Maybe with this camera. Then you can see the setup. Switch camera. Okay. So this is the my bench multimeter, which is just a multimeter now permanently connected to USB, isolated USB. So it's always charging the battery and then to USB also to read out the data. And just next to it, this thing here, this is my USB charger power bank. So whenever I need to charge something over USB, I use this one. But you see the display is completely off. Which shouldn't happen. And this is the first time I saw it. I've seen this. Let's unplug and replug it. Unplug. There's a lot of charge inside. So there are 6 outputs, and then it shows a rough, very rough indication on how on the current consumption. It's very rough. It's really bad. Plus minus 100 milliamp. Okay. So now, see, it started correctly, and let's try to see if I can make it bug again. It stopped really using the display, but in this case, the USB is on. Why don't you see this bugged again? I don't know why. Yep. I need a better power. I need a better hub to have something more stable. So now, okay, let's switch back. Seems to be stable. So this doesn't switch on power. The hub here doesn't switch on power as long as there is no enumeration. This I didn't know. It makes kind of sense. So here we know we have feed. Why is this seeing? It is seeing feedback power because it's plugged in. If I unplug it, there shouldn't be no feedback. Is it intended this way? Actually, it's not using power. When this is plugged in, my schematic says don't use USB power. Let's just remove it. And when it is plugged in, there is feedback power, which is not something good. But you shouldn't plug if you don't want to power it. So that's okay. So we still have 5 volts. Let's switch off. Switch on. We do have 5 volt. We don't have any power. So it really only works with enumeration. Let's try out. Up. This is enumerating and we see the dips. Now let's check if it's because of the USB hub, of the fuse, or because of the upstream USB. Here, which is the input, there's no dip. Sure, it's a bit noisy, but there is no dip. Here on the output, this is the 5-volt output. We see no dips. What's happening? So the fuse is not the culprit. There is a dip at some point, I think, when it starts, but it's really brief. Let's put to normal. Yeah, you see, it's really brief. It's not enough for the fuse to trigger. Is it? No, because the fuse doesn't recover in 20 milliseconds, and it needs a bit of time to recover. There is a dip. Is this dip enough to make it reset? That's the input of the fuse. There is no dip on the input. There's a dip on the output, so the fuse does trigger a tiny bit. Let's remove the fuse and let's see if it's stable, more stable. I think another reason might be this. Although it should be off, it might, because if we look here again, which is another 5-volt point, here we clearly see the dip. Up. But isn't it the same 5 volts? The same 5-volt rails? Oh no, one is after... Could this change? One is after some resistors, the transistors, which switches on and off the power. Okay. Could this be the issue? Because here we clearly see like 50, 1, 2, 3, 4, 5, 60 milliseconds dip, which is switched off before it gets switched on again. Here it's less than 5 milliseconds. So something else is cutting power. And this is the 5-volt rail. Here are the two MOSFETs. So I think it's going through this ferrite bead. And this ferrite bead, at the end, we also have this tiny dip. Then it goes to this MOSFET. There are two MOSFETs. I think Q3, Q4. And then it's going out to 5-volt, which is this one. And here there's no dip, so it's not this one. It might be this one. Here. Here we see the dip is not that large. Is it the same one? Should be the same. Okay, it's not that large, but here we still see the dip. This is the output of the first MOSFET. So it goes in here, I think. Let's check the schematic. Let me get the schematic. That's the schematic. So it goes into Q3. Q3 pin 2 is the input. Pin 2 is the input. This is pin 2. That's the input. We see the 5 milliseconds dip. That's okay. Pin 3, which is this one, this is the output. And we see the dip here. So we have an issue on the gate, which is pin 1. And on pin 1, what does it look like? Yep. You see there is a switching on and off of the gates. This one. And who is switching on the gain? the gain is switched on by local power. So by default it's switched off through R4. You also, do you have the schematic? Let me put it where it belongs to. Here, this one. Okay, so the power input has an issue. Let's see why. So it's put low by R4, so we switch on, we disable switch on. It could be pulled high by local power, which is tied up to 5 volts. And then VBus. No, that's not VBus, that's not the right one. This is the old version. Yeah, that's version 0. This should be trashed because I don't need it. Oh, don't trash it. But I don't need this version anymore. That's also version 0, isn't it? Yep, that's version 0. I don't need version 0. I know I've changed it. This is version 0 also. Up, don't need version 0. This is version 1. Okay. So it's pulled down by R4. It's pulled up by 5 volts but as long as we don't have the VBus, it's not gonna be pulled up as long as this is not pulled up. We won't have 5 volts, meaning it won't be pulled up here. So what's pulling it up is this one. Here we have the VBus, and the VBus, the VBus is pulling it up. No, it's not actually. It's not pulling it up because this is not connected. This is also not connected. So when this is not connected, it is tied to ground. So this never pulls up this thing. This part also never pulls it up. I have a huge design flaw. I don't even know who causes the pulse we see on the oscilloscope to pull it up. We also have VBus, which is connected to the USB hub. So let's try something out. So now it's blinking. What if I just put a connector? So yep, is it this one? No, that's not this one. My power input has a flaw. It's not enabling. Why? No, these are. Sorry, these are not NMOS channel. These are PMOS channels. So they are enabled by default by R4. Okay, now I get it. So they're enabled by default. So by default there is power going to R4, and then if so there is power going through these two. Okay, it was. Mistake of mine. I did do something which is not good here. Up. So there's some wrong thing. These are P-channel MOSFETs. So they're enabled when they're pulled low. By default, they're pulled low. So by default, they're enabled. They are switched off by 2 things. Either they are switched off by here, this 5 volt when this is connected, but this is not connected. So this can't. So in here, R2 should always be pulled to ground. So this should never pull it up. This should never pull it up. It could be pulled up by this thing, R3, but R3, as long as there's nothing plugged in, it's always to ground. So nothing should pull this up. Who causes this local power to be pulled up? Local power. That's also that's used by the USB hub, and the USB hub. Do I have to say that this is when it's, what is it per default? Suspend indication. I think the mode is not the right one. So let's plug this in again. Can we see? Run. So, sorry, wrong pin. I need. Let's use the second one. On this pin here. This is. Why is it so high? Let's put it to 2 volts. This is pin 2 is. No, it's pin 1 we should probe. Pin 1. Yep, it matches. Okay, it's very noisy because the ground lead is not connected. Now the ground lead is connected. Pin 1 is the gate. Yep, it does match. No, you're not triggering. Yep. Yeah, you see it goes down because this local power is getting pulled up, and the only one which can pull it up is the USB hub. And the USB hub, because it's connected to this pin 45, which normally is a local power indication, so it should only be an input, it should not be an output. Pooh. Why? Again, because the chip, this is something I really don't like. I might have damaged the chip because I soldered it incorrectly. This could be a cause. So let's remove this chip, put a new chip in. And this will exclude any issue, any potential issue that I've damaged it because I reheated it too often, or because or because I put it the wrong way around. Let's do that, because I don't want to spend now hours on the data sheet, but I think this is not damaged because everything else is working correctly. I think that's not the issue. The local power indication, I think this is the issue. Up, and when it boots up, it's probably not an input, but it's an output, because it doesn't have yet time to read the EEPROM configuration, or my EEPROM configuration is wrong. We will check afterwards. For now, let's desolder it and resolder a new one, so I don't have doubts about it. But I really don't think that this is damaged. Let's put some flux. I'll need to clean it up and so on. Up, 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 up. So there is flux. I'm blowing 400 degrees Celsius air on it. Now I just have to wait for the board to heat up so I can unsolder it. Desolder it? Unsolder it? Desolder, I think. So I can lift it. Let's say lift. What's weird is, no, that's not weird. When we provide power through 5 volt, this is always enabled. Actually, it doesn't do it. So I think it's, well, let's just remove the chip because we might have other issues. I think this chip is fine. Should I don't want to get my heating plate. It's not such a huge board. It's only one part. Come on, heat up. Now it's going off. Up. Okay. Let it cool down. We'll have to clean the pads before we can put a new one on it. Let me get a bag where I will put it and name it. So, small ESD bag, pen, that's an USB 2517, something like that. Yeah, USB 2517. USB 2517. Maybe defective. Wrong orientation. Soldered, wrong orientation. So now we will solder a new one. If the new one exhibits the exact same pattern, it's very likely that the chip is not damaged and that the chip is fine and I can reuse it. For now, we'll put it in the bag because we don't know. Up in the bag. I'm not wearing an ESD strap, but at least I have some ESD mat. Should be enough. Let me switch off the oscilloscope. Okay. I should have still 3 of them. Yeah, I've ordered 5. I used one for the V0. This is for the V1. And we will solder the next one on the V1. Yep, I need to clean the pads. So up some solder braid. Let's cut it. I need to put some flux on this solder braid because it is not fluxed. Up, we have some flux on it, and now let's clean the pads. They're not even, and this makes it hard to solder on them. They're not even because of the solder. Should have put more flux. That should be sufficient. We just need to heat up the board. Also the braid, and then we can start sucking the solder. Yep. I push too hard. Come on, solder, on solder. Get warm. Do you want me to get the other soldering iron? Crappy soldering iron. Nope, wrong tip. I need the large tip. Which one is used for plastic? This is not used for plastic. Oh, the power wasn't any. What? Who switched off the soldering iron? That's weird. Okay. This should have plenty of heat and should be able to suck everything. And it does. Try, when you use soldering bread, try to go along the pad direction so it doesn't rip them off. At least there's less chance. It can still rip them off because the glue under the pads, under the copper, can get used. It's not very flat. Okay, that's flat enough. Up, up. Let's clean. Up. Up. Some wipes. So this removes the solder flux, which is also thick. And yes, we'll put more solder flux. Some flux again, some new one, some fresh flux on the pins. Let's try to put just a tiny blob of solder on the center pin. Then let's keep it warm. And maybe I should do it with a soldering gun. So it heats up, so I'm sure that it connects this pad. I don't know. Else I don't have a good method to solder the pad. There is a ground pin also on the sides, but it's only just one of them. Pin 1, don't get it wrong this time again. I did it wrong once. Yep, I need to put some heat. On it, put a tiny bit more, not too much, that should be sufficient. And let's heat it up. Okay, I see the solder starting to reflow. Yep, let's put the chip on it. Let's try to center it. Up. That should have some kind of ground connection. Okay. And let's solder the rest again. It's only the third time I've soldered this. chip, or fourth, I don't remember. Flux on the sides, up, up, and let's go. The last one is soldered correctly. Okay, this side looks fine. Let's leave this pin on there. Maybe you want to see a bit better soldering I'm doing, but you won't see the pins. This side is the next one. Let's clean the tip to remove the old solder. Let's put some new solder. I'm getting better at soldering this part. And QFN in general. Yeah, most and most. So I was really comfortable soldering QFP. But now QFP, like, yeah, everything started with dip chips, easy to solder, it's through hole. And then it went to SMD QFP chips, which is something a bit different, but it's not too hard. And now lots of chips don't do any QFP anymore, but just QFN. Save some board space and some lead costs. I have to pay for the lead frame. And for surface mount soldering, so everything which is hot air, it absolutely makes sense. Hot air or solder or reflow oven, it absolutely makes sense to use QFN. But for hand soldering, it's a tiny bit harder, still doable. I get solder bridges, that means that there's not enough flux. So let's put some lube on it. Yep. Yep. That's the third side, and the last one, I still see a lot of lube on it, so that's fine. Let's clean it, and let's visually do a recheck. My alcohol. Just wait until it soaks a tiny bit, and let's rub it. And you see, it is getting yellow, so it means that there is some solder which is removed using these wipes. So this side looks fine. This side doesn't look fine. Is it soldered? Did I miss it? This doesn't look soldered at all. Like, not at all. Probably completely forgot this side. the chip isn't aligned perfectly. Still will be sufficient, but it's not perfect. Better. Let's clean again. And I don't remember the sides I've checked, so let's check all the sides again. This one looks okay, not perfect. There's one pin which doesn't look perfect, but it looks soldered. Probably a pin I don't use. I don't know. It's not right. This side looks good. This side looks good. This one looks good. This doesn't look perfect, but it looks okay. And this one looks good. So last, it looks okay. There's one pin which doesn't look too great. So now we've soldered the new one. If we get the exact same behavior, we can say that the other chip is not I will say that the other chip is not damaged. That will be my conclusion. It might still be, but I'll say it's okay. Up one, so that's the 5 volts, and we just have to plug in. Let's remove it from a solder stand. Yeah, we get the exact same behavior. So I declare this chip as perfectly fine. Let's remove that this is defective. And it means that at the beginning, this chip sends out a signal to local power. And we have to check the datasheet why it does that. Well, we don't know if it's exactly the same behavior. So for that, we need to provide 5 volt power. 5 volts up. 5 volts, power on. Yep, this LED is on. Up, and then... No. Well, it's not the exact same behavior. It's again not... Yep, it's again going into a weird debug mode. Yep. And it's not enumerating. So there is something wrong with high speed, low speed device. No, that's not it. There's something wrong with how I use the chip. Yeah, it behaves the same way. So the chip is not dead. We'll have a look at the data sheet of this USB thing. Let me wash my hands. Up. Now they're lid free and I can lick them. Get something to drink. And the USB hub is dead. The USB hub, I mean the multimeter. But we don't need it for now. We can restart it, but TMM, we don't need it anymore. Let's switch to the laptop side. Full screen? Full screen, yep. And yeah, we can leave that. So, the data sheet of this thing, data sheet, maybe the EEPROM configuration is wrong, we'll check. Let's see on on the reference design how they used it. Local power indication, it pulls it up. Wait, oh no, this is another pull up. So it pulls it up. This is not a pull up. This is 10K. 100K is a pull up. So reset is pulled up, that's for sure. Reset is pulled up, but this is not a pull up. Well, it is. It is a strong pull up. I need this local power indication because I want to be able to switch, but I can do it another way. We'll have to check. So here, because it's 3 volt, and is there nothing, something else connected? Local power, external base supply, local power. No, it's not connected to anything else. So by default, it is pulled up, and they're using it as local power. Now let's look at the data sheets, what it says about this chip, about this pin. F9, pin configuration. Just below it, there should be the pin description. Here. We have local power. Probably just cut the trace. Here, local power. Active status suspend LED and local power non-removable strap option. Suspend indicator indicates the USB state of the hub. That's probably what it uses in the beginning. Yeah, unconfigured or configured, and in USB suspend it's negated. Asserted. What does asserted mean now? Does it mean that it's high? Yeah, USB is configured. And I think this is what's happening. It goes high when it says USB is configured, and this switches off the power. So it's using it as a suspend indicator and not as local power. Local power detects the availability of local power. A self-local power SUT is not available. Low. Do I use it correctly? This is a downstream port. Where's my schematic? Here. Local power. Local power, when it is low, it is self-powered. So when it is low, this is, yeah, it is self-powered. And as soon as there is external power, yeah, as soon as this is connected or this is connected, it goes high. Yes, it does. No. Yes, it does. This pulls it up. Either this pulls it up. When this is connected, the 5 volt pulls this one up. Or if this is connected, the V bus pulls it up. Well, pulls it up through D3. The power goes in. It should be high enough to be detected as high. If this strap is enabled, so this is input outputs. Non-remove option. If this strap is enabled by package and configuration settings, here, interface behavior. This is what we need afterwards. This pin will be remapped to negotiate and terminate and connect. All ports are removed. What? I don't think I'm using this. We'll have a look. Let's have a look at this part. Our thing is here, 2-wire EEPROM normally, 011, and this should be fixed. Let's check it out. Cell 2 is grounded using 100K and nothing else is in the way, so it's 0. Cell 1 is pulled up, so it's 1. And then cell 0, which is this one, is pulled up by VCC. So 0 and 1. Up. All strap options are disabled, so the non-remove is disabled. This is clear. So the last part is maybe our EEPROM configuration is wrong. I do see in-circuit EEPROM programming can be programmed via ATE. What's ATE? By pulling reset low, which resets the interface EEPROM and allows. Okay, yeah, I don't know what they mean with ATE, but yes, this is what I'm doing. I'm programming in circuit because I'm holding reset of the USB hub. Via ATE, is this defined somewhere? No. Maybe at the top. Maybe automated test aperture. No, automated test EEPROM. ATE. No, nothing defines it. Nope, it doesn't tell what's ATE. But yeah, it's just external programming. So let's have a look at the bits. EEPROM register sets. Config option, non-removable devices. I think this is somewhere in these config options. Let's have a look. PID, VID, we don't care. LSD did self or bus powered. Selected self or bus powered. We here. Dynamic power is enabled. This bit is ignored, and local power pin is used. So we just need the dynamic power switching, which should be enabled. So let's check in our EEPROM. EEPROM values. Bus powered. Dynamic. Bus powered. I'm telling it's bus powered. So it's not using the dynamic part. Okay, I wanted to debug it, and debugging it now made some mistake. I think these are the same values. These are for the same bytes, option bytes, because I'm commenting one of them. Port map. Let's check. Up. Self bus power. I think it's the same value because this is the next one is reserved. No dynamic. No, there's something wrong here. Something wrong with my bytes. So register 6, device ID MSB, device ID MSB. This is register 0, 1, 2, 3, 4, 5. Yep. Line 5. This is okay. But then we have a reserved. So here we have, this is self power. Bit number. Okay. It's bit numbers. Yeah. So this is the same register. It's config byte 1. Let's name it correctly. Config byte 1. That's config. Whoops, that's not what I wanted. That's config byte 1. And then we have dynamic, right? This is the same. Now here we have dynamic. No dynamic. Dynamic power enabled. Okay, so it is not enabled. This is why. This is config byte 2. And they don't name it the same way. This datasheet, the more I see it, the more I'm annoyed that it's really bad. So much information not inside it. That's config byte 2. Config byte 2. So we need to fix it. We know we changed it because we wanted to debug, and now we need to fix it. So this is config byte, so port remap, this is config byte 3. 3. And the next one is an R device. Yeah, non-honorable device, so that's okay. Config byte 3 is the same. So there are 2 bytes we need to change. Although configuration, let's have a look because we've commented them. Let's look config byte 1. Self-powered, we don't care. So let's leave it at 0. I put it 1. Superseded, okay, 1 or 0, we don't care. Now let's move this up. So 1 or 0, we don't care because it's superseded by dynamic afterwards. Then we have reserved. Reserved is always 0, else we might land in some weird debug mode. Then high speed disable. We want both high and full speed, so this is 0, this is fine. MTT, we want 1 per port, so this is 1, that's fine. So this TT transaction translator, I think it's kind of a buffer. I don't know exactly what it is, but I see it as a buffer per port instead of a buffer for all ports. Makes it faster, I think. I don't really know. Then EOP, end of power, end of programming, end of packet. End of packet disable. Generation is normal, we wanted 0, this is 0, this is fine. Current sense, over current sensing, we want individual per port, so 0, 1, 0, 1, that's okay. Power port switching, individual ports, we have that, so this is 1, that's fine. Let's have a look at the next config bytes. Why do I put some spaces in between? So this is the config byte 2. Config byte 2, dynamic auto switching. We will enable it high. Then reserved 0, that's done. OC timer, overcurrent timer, as fast as possible. Yeah, let's put it as fast as possible. 1, 2, that's okay. That's 0, 0. Compound. We are not a compound devices, so 0, that's okay. And reserved. The last 3, 1, 2, 3 are reserved. Okay, so let's reprogram the EEPROM. And this time it might be the right values and the behavior might be okay. Programmer. Ah, yes, the stupid programmer. Let's use it though. I need to build a fixture of some kind, because it's getting annoying, and I will do it now. Let's build a fixture. I think they're here. Project box here. Yeah, perfect. This is sub package, and we will just solder the cables on this sub package corresponding to what we need. Should I cut these leads? Yeah. It's not the perfect way to do it, but it's the fastest. Or do we want to do it correctly? Probably do it correctly. Yeah, we'll do it correctly with crimping. I'm not in a mood of crimping. No, let's cut them. We can always use these leads. And instead of crimping, I still need to make one cable out of it. Oh, crimping. Ribbon cable. IDC cable, I think they're in here. IDC cable, and somewhere here I should have ribbon cables. I can reuse this row. Yeah, colors are always useful in this case because we will separate them. So we need, how many did we need? 1, 2, 3, 4, 5, 6. The 3 volts will be provided external probably. So 6. I don't need IDC. Yeah, I'm too lazy to crimp cables. Let's just reuse cables. This is good if I want IDC connectors. I'll just reuse these cables. Let me switch back to the bench. So first off, so we don't need to use this tape, we will put a 6-pin connector. So this is stable. Female header. We have DuPont cases, they are here. Do have something with 3. We don't have something with 6, but we have plenty of other ones. We need it. Yeah, we have plenty of these ones. This will be my fixed cable for this device. So, oh, I can salvage these DuPont cases, although I don't need to. Still do it. And I'm using a needle to remove them. Up. 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 I think this is the last time I will see an EEPROM outputs. Should we cut it in the middle? Let's cut it in the middle, and this makes some DuPont cable we can use to solder. So we can debug this. Let's put this case in, and one is brown, which is quite okay because it's close enough to being black for ground. This way you all go in. Up. They're all in. Not completely, now they're all in. And up. Let's remove it. I'll never use that. Don't need to put it somewhere. I'll never use it because when you cut it, it's not really flush right here. It's not one of this. It's still thick, so sometimes it's a bit of a pain. And then if I want something correct, I have a 3-1. So this is the first part. Second part is these things. Up, 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 up. Can I use that? Let's try to gang strip these wires. No, that's what I thought. It's not meant for gang stripping. 1, 4, 5, and last one 6. And now I need to solder them on this adapter board, which will be used here. So this is pin 1. And what's the default EEPROM? What's the default EEPROM pinout? Let me get the pinout. Let me get my data sheets. I do have plenty of data sheets. Maybe there's even one here. Which one is it? Yeah, this one. Yep, that's the data sheets. That's not the one I want. Write protect, this one. Oh, it's not the same. Probably this one. So ground is pin 4. This is pin 4. Let's put some LED on the pads. That a tiny bit. Let's put some LED on the terminal, the cable. Okay. Ground pin 4. And I think I also will need to put reset on it. Because, yeah, reset N, so negative reset, so it's asserted on low. Second one is red. This is VCC, this is 3.3 volt. I'll still solder it, although it can't power the whole board. And it will probably say, overcurrent detection. But I'll still put it there. That's pin 8. Yes. Afterwards, we have reset. This is also connected to ground. So this asserts reset of the hub. So we can talk to the EEPROM without the hub talking to it. Then we have write protect. Write protect is pin 7, which is this one. Pin 7. Okay. Will this hold? Now it will hold, but this one is a bit too near to the edge. Yep, it's shorting with pin 1, which I don't want. Okay, then we have the clock, SCL. SCL is, it's these 2 pins right here. Do I have? I might have a clip. No, it's too near the edge. I wouldn't be able to use the clip. Okay, that's the clock. And the last one, we check it. It's the data. Data is this pin. Yep, that's soldered correctly. And now we have our programming connector. I would put some hot glue on it once I know it works. So now if we put it this way, we should be able to program it, and we will try. Here we have USB. Tack. Full screen. Okay, let's try to program it. EEPROM. So generate and program it. Overcurrent protection. Okay, this was expected. I need to provide 5 volt externally. Do we have another USB cable? This one. Up 5 volt externally. Okay, verification okay. So now what we hope is that this fixed, so the programming works, meaning I can put some hot glue on this thing. So it doesn't break too fast. But I still need to figure out pin 1, that's for later. Now what we want to do is figure out if it's still reset. So well, let's just plug it in and see if it does still reset, or if now it works as expected. It does not reset, and it switched on the power. Okay, so there was no issue with the hardware, it was just my stupid debugging flags which did that. We still have sufficient power to power all downstream ports. That's for sure. That's good that it indicates it, because we don't have external power. Because it's not powered up. So that was the first issue. Maybe this also fixes the other issues. I don't think it fixes the overcurrent issue we had on here. And the power switch on and off. Does power switching on and off work? Let's try. So if I plug it in, it says, I need to show you what I'm doing. Camera, come here. Second camera. So it's not up. Let's switch HDMI. And yeah. So power is on. Normally, if I put this high, so switch center, this should switch off, and it does switch off, and this does switch on. Perfect. That works flawlessly. Overcurrent sensing doesn't work because we didn't solder the diode. We will probably solder it again, but we had an issue with that. Maybe it was also EEPROM configuration issue. That would be great because it means that our board works flawlessly and we have no modifications to do. Do we? Prevent feedback. Okay, feedback. Use SMD switch. Okay. Check fuse spec. No, I don't need to check the fuse spec. This is done. I don't need prevent. Yeah, I know prevent feedback. That's okay. I don't want that when power goes in here, it feeds back to the other ports. Shouldn't be too much of a problem, but it's a tiny bit of optimization. It's nothing groundbreaking. So this, we want to remotely switch it on and off and see if this works. Did I desolder one of this resistor, which is actually taking care of that? No, it should still be here. So how did it work? USB hub control, I think. USB mode switch, U hub control, yeah, that's it. Do I have a README? No, I don't have a README. Let's put a README because I don't want to figure out all the time. README.md hub to switch on off port. Normally I should have it in the history. It is called hub, GitHub. Yep, that's for sure. That's in my history. This. Okay. To figure out which hub supports power switching. There's one which is listed, which I'm almost sure that it's not powering, doesn't support hub. We'll see. Power switching. I think it's L, like list, something like that. USB hub control, force, reset, repeat, exact, search, list hubs by attached device description. Limit hubs, no. Limit hub by attached device description? Then what does it have to do with search? Okay. Toggle all off. Without option, show status of all smart hubs. Okay. No, it doesn't. No compatible devices detected. There were problem accessing USB. Maybe I don't have the rights. I typed my password wrong. Okay, I just didn't have enough authorities to access the hubs. USB hub control, and we have 3 hubs. This is mine. 7 hubs. I don't know what PPS means. This one. Low speed. It's the one on the bottom. It's one of the old D-Links. And I have nothing on port 3 and 4. I could test. I don't want to test it now because I don't want to disable my mouse or my keyboard. Enable power. So it has the power attribute, meaning I should be able to switch on and off. Then I have a second one, a 4-port. It's the same one. Yep, it's the same one, but it has 2 chips inside. And you see somewhere my keyboard is there. So on one side I have my mouse, and on the other side I have my keyboard. And then my printer, and this is another hub. And on this hub, this is the one I have on my desktop. So this is one of the old D-Link hub, which I really liked. And I still like it. It's very robust. Do I have, I can't, it's hidden somewhere. I can't show it to you, but I really like this gray old D-Link hubs. Although, because they were robust, but you see they have a flaw. It's that they have 2 hubs inside. It's 2 times 4 pins, and out of that they make a 7-port hub, which is not perfect, but else they're pretty robust, and it's not crappy. So they have D-Link has plenty of versions of their one. Let me show you which one I mean. D-Link hub, USB hub, images. These are the new ones. There are plenty of models of them. I have several revisions. I think D and E, I think one of these revisions. And I don't like them. They even appear 2 times at HID device. I think this is so you can reprogram them. This is really badly done. So inside is not that great. You cannot switch power. It's 2 times 4. You see the quality has a lot degraded, but the one I liked and which is rare to find, it's this one. This one, this is the one which is listed. And I think it's revision B, something like that. And I have revision D C, G, and E, or D and E. I don't remember exactly. I've listed it somewhere. And these are these ones, which are not, but these ones were good. So if you can find them, they're still okay. Not as good as mine, but still okay. I think I'm not that surprised that it supports power switching. Else, I don't know about other hubs, good quality hubs, but mine is a lot better, although it requires a lot more work. It's not off-brand, but at least we have this one. Then I'll just show this value to switch off ports. Port 2. Let's switch off port 1. Action. And I still have studio, which is fine. And we are on port 3 because we're directly connected. So this is, I think this is the USB hub bus. So this is the one directly connected to my computer, and we are directly on port 3 of this bus, something like that. Normally, if I switch off, this green LED should switch off. If that's the case, then we win. Yep, you see, it switches off. So power switching on and off works. Action on. And it switches back on. The only thing which now doesn't work is the overcurrent sensing. And maybe it was because of the misconfiguration of the hub. So let's try the overcurrent sensing on 2 locations. The ideal location would be this one, because it doesn't recover immediately, and the other one would be this one because it recovers immediately. But we saw that it has issues with the recovery. Power switching works. That's great. Let's just switch off power. Here, power off port. Okay. So view, I don't want the sidebar. Where is the sidebar? Sidebar here. So let's try to switch on in one location and see if it works. Yeah, D106. Let me show you on the schematic. These are the 2 locations. Again, if it's here, so this is an overcurrent protection. Actually, I could leave it here. This is an overcurrent regulator, a current sensing regulator. I don't know exactly how it's called. This will always limit the current. Actually, this will always limit the current to 500. I will limit the current to 560 milliamp. So here, no matter what happens, it will limit this current. And actually, I might leave it here. The problem is that, yeah, for example, if the chip does overcurrent sensing, it will switch off power. We're switching off power here. So if it switches off power here, then there's no way that this goes high. This goes high again. This goes high if there is no current use. There is one way to go high. This is pulled up by the microcontroller. So it might feed in here, and this might pull up enough these pins, these 2 capacitors to charge it, and then at one point it will be recovered if the target is not draining too much current. The other way around was here. So as soon as power is disabled by the microcontroller because it senses current, it will cut the power here off, meaning here there will still be directly the 5 volt growing through the fuse if the fuse didn't trigger. So it will immediately recover. And this might go in a situation where it's switching on and off the power all the time. So I would like it to be here, but I don't know if it recovers. And if it doesn't recover, I have to put it here, but I don't know if it could cause a toggling on and off of the overcurrent sensing. no ideal case. And I think the overcurrent something on other chips on the reference design. Where's the reference design? Here. On the reference design, they use another chip, but it's the same. Here. This mic 2026. This is really designed for USB hubs because it has an overcurrent limit set to 500 milliamp. The one I'm using here is not set to 500 milliamp. You can program it using this set pin, and I've set it to 560. And it has two of them, so it's meant for multiple ports, and it has two output flags, and the flag indicates the overcurrent sensing. So if there is overcurrent, if it reaches the 500 milliamps, it plugs it low. So I think this will be the same way. As long as it draws current, it will be pulled low. So it's probably the same way as the one I want. But, well, not the one I want, because I want to pull... maybe I just have to pull it up. We're using a 10K resistor, something like that. So it allows recharging. That might be good enough. I didn't put one on the schematic, but I should have put one. On OCS1, I could pull it up. Yeah, I could put it up using something like 10K. And this 10K would allow it to... It is internally pulled up. This is current sensing. No, I think it's fine at this position. So let's solder it on Q106. Let's switch to the bench. Screen, no. Bench, yes. And let's switch back to the bench. I don't need this anymore. Oh, this is this one. This is this or this. So let me get, I don't need this anymore. Let me get the tiny resistor. Up. Put this away. This away. Let's clean the batch a tiny bit. You go here. I don't need you. And I don't need you. And I need my, I think it's power MOSFET diode. It's in my diode book. SMT books, diode. I don't think it's a Schottky diode. It is. It's this one. Still have enough of them. Yeah. So that was one. Sure, we'll need more than one. If I desolder them, I don't want to reuse them. Too much of a pain. So I will have issues because this is not flat. I could use hot air. I have to first find out here. This way. This went super well. But it's just one side. Let's try to see if it works well on the other side. No, it doesn't. And we had an issue that it didn't start and it was drawing too much current. But maybe it was because it was misconfigured. So let's try it again. USB hub. Do we see the journal control? No. I kind of see it, but not. So this I don't need anymore. Stop capturing. This is the journal control. Does it restart or does it enumerate? Let's please work, please work. It doesn't, and it gets, I think it also draws too much current. 5 volts. Yep, it draws 100 milliamp, which it shouldn't. So not at this location. I think at the beginning it's a bad idea. So not at this location. It draws too much. Well, why would it draw to so much? Yeah, it draws 100 milliamp at the beginning. Nope, we won't put it here. But why does it do that? Then it's the same behavior as the other chip. So definitely the other chip is not dead. At least not on pod 1. Might still be on the other ones, but I don't think so. Okay, you are, oh no, you are gone. You can go on this side. Up, gone. I can't read which side is which one. So let's put it, let's try if it works again. Yep. Oh, this way. Nope. No, center is off, I think. Edge is on. Okay. Now it works again. So there's some flaw. We can't put it here. Now I'm afraid we will run into a loop. Let's just try on the other location. I need to check if I did solder it correctly, because it's so tiny I might misread the line. Up, multimeter, up, go into diode mode. This is plus, this is minus. Does it read 0.3? Okay, so it's the right direction. And let's try if it works this way now. If I plug 5 volts, I should not see. Well, it doesn't start, but it doesn't. We know it doesn't start because there's no V-bus, so it no V-bus detect, but at least it doesn't draw 100 milliamp. Now if I plug it in, this seems to work. Now I have to test if it does a short detection, overcurrent sensing detection, and what happens when it does overcurrent sensing. So let's take one. Where is my superb debugging connector? And this way we can short out and we can test what happens on the pins. I hope also this current sensing now limits hard the current, so this hub doesn't reset, which was the issue on the last time. Up. So we have a dead short. This is not like 500 milliamp sensing. This is really a dead short. And if we short, it should do overcurrent sensing. What happens if I leave it shorted? Tack. It didn't tell overcurrent sensing. Is the USB hub still here? It didn't do any... It didn't report? It doesn't report it. Okay, this is bad. It doesn't report it because the... Why doesn't it report it? Because it was too fast. So that was the issue. So okay, it's not even reporting it. that was the issue. Okay, it does recover. I think the fuse blocked the no, not the fuse. Why? This is current limiting, so it should limit current to drawing 500 milliamp. This is weird. Let me use the oscilloscope. I have to enable the oscilloscope for you. Oscilloscope. I have to start the capture. Start the capture. Oscilloscope. So let's try to measure on the output. I think it's this one. This is, let's put it not to normal but to auto. This is the output. This is the 5 volts. If we short it, we see it goes to 0 volts. That's fine. This is, oh no, it's not 0 volts. It's almost 0 volts. And it can recover. Is now on here. What I'm probing here is the second, say it's the cathode of D1. Why is it? It's of D104. And let's check if this one goes low. Now we have to trigger normal. So this is even the output of the fuse also. Tack up. It did. Oh, tack. Okay, but it's not. It is still high. So the overcurrent sensing doesn't just limit at 500 milliamp, it shuts it off. So we don't detect an overcurrent. Yeah, it is high. Let's try again. And it recubes. So there is a tiny dip. Why doesn't the hub detect it? Because there, okay, there's a tiny dip. Normal. When I short it, there's a tiny dip. It's not enough. It's not low enough. The current sensing resistor, the current sensing regulator doesn't pull it completely low, so it doesn't detect it. Okay, so we have no way to detect it. So the current sensing is broken currently. I'm still wondering why it draws 100 milliamp when I connected the T106. Because if there's voltage output, it shouldn't draw anything. Maybe power is not on yet. So this should be low, and this is low when there is a short. And yeah, that should be the right way to do it. This is high. That's normal. And I don't know how much it draws actually. Let's put this. Now this should power everything on. I'm using 100 milliamp. Oh yeah, I'm using 100 milliamp. So 3 milliamps when there's nothing going on. When I short, oh, this is 300 milliamps. So this is probably because of the current limiting. But I'm using 300 milliamps, which is quite a lot. Here we have 5 volts, which is going in. So the short is not completely off. I probably have current going on through here. Let me get another multimeter, and this way we can figure out how much current it draws. So this will go into 10 amp mode. 10 amp. I'll never draw 10 amp. But the other one is just 0.5. I don't want to blow the fuse. Com and 10 amp max. And second multimeter. You can't see it. This reflection makes it so you can see it this way. Now you can see it somehow. Which one is ground? This one is ground, although it doesn't matter. Can flow both ways. Does this? How much does this draw? Yeah, 324 milliamps. Exactly what the thing does. So the current limiting resistor, the current limiting thing works. It does limit the current. It doesn't shut it off. But actually, well, the power should be shut down. No, it's not shut down because it doesn't detect that there's an overcurrent. Does it? No, I think the hub doesn't complain that there's an overcurrent, so it doesn't shut it off. And since it doesn't shut it off, so the LED is not on because the current draw is just still too high and there's not enough power for the LED to go on. There's not enough voltage because of the short, but the hub doesn't switch it off. And we have 300 milliamp going through there all the time. And since we are current limiting, the fuse doesn't trigger. I just find the fuse is really the last resort. Oh, this is high, this is low. No, this is high. Okay. So it's the wrong position. It doesn't detect overcurrent, and we are by far on overcurrent. Although it should be 500 milliamp, but maybe we just don't have 500 milliamp. No, we do have 500 milliamp. It should be able to draw 500 milliamp. Why it doesn't? Maybe there is the fuse limits it. No, it doesn't, because there's 5 volts. If there's 5 volts here, we are at 5 volts. Why doesn't it draw 500 milliamp? Maybe because of some resistances. I don't know. I should be able to draw 500 milliamps before it triggers, and we can try it out. But we know that the overcurrent sensing at this point is not a good idea. Do I just need to put a 10K inline resistor so it doesn't draw current from there? That might be the issue. That might be a solution. It must be a T106, but we should limit the current because it seems that it doesn't start correctly. Let's see. Small break. I need to drink and I need to go to the loo. I'll see you in 2 minutes or so. I know the right solution. The right solution is to use the correct current sensing, current blocking switch. This one. I need one which has an output. That would be the right solution, which indicates when the current is exceeded. But for now, what I will do is figure out. So almost everything works. I need to figure out how one way to do it correctly. On D106, this can't work here. It doesn't work because this just doesn't dip the voltage fast enough and strong enough for it to go down. So it could be here, but here we have an issue that it draws too much current, or that we have an issue where probably draws too much current. So we'll put a 10K resistor on there and see. So let's switch this off. Let's switch this. Remove this. Let's remove this. Tick. Up. That's done. We will try to put a 10K resistor inline to limit the current we go through it. Maybe it will not be able to recover. The issue, yeah, the other issue I have here. If this draws too much, no, the value should be low enough. Problem is here, this just limits the current. So there might still be some voltage, and this doesn't cut it off. So there might be enough voltage so that this doesn't detect the voltage drop. I don't know. And then doesn't detect overcurrent. Might be the case. I don't know, but we will try it out with just with a 10K resistor. So we will put a 10, but I need to just change the chip and use a chip which actually has an output flag when there's overcurrent. That's the best solution by far. So 10K, 2K, 1K should be sufficient actually. Let's put 1K. We just want to limit the current. We don't want to use this pull up. So it has enough time to start correctly. So just let's try with 1K, 5%. Take this. We have to remove this resistor, tweezers. Might not be the ideal solution, but it might work. This is where desoldering tweezers would be useful, or just getting the hot air gun. Or the second soldering iron, that's also a solution. Okay, this is gone. So here we have this part, here we have this part. Let's put the 10K first. And now we want actually to have tombstone. This way. Well, let's put a bit of flux because I think the solder isn't that good anymore. Okay. It's not perfect, but it seems to hold. And now you. Yeah, this is the cathode mark. Okay, it's not perfect at all. To clean my tweezers. Yeah, it's not holding. I should have put a footprint for a resistor, for an inline resistor, and then put it to 0 ohm while debugging. Yeah, I should. This will never touch the 10 ohm resistor. What is this, smaller than the 10 ohm resistor? 1 kilo ohm resistor? And this is not meant to be. This is not meant to be soldered upright. So on the resistor it works. On the diode, it doesn't. Could use another diode though. One which is not that tiny. I have enough Schottky diodes. Yep, let's use another diode where we can probably better do that. Any Schottky diode might do the job. Diode Schottky. This is a bit too huge though. This one, diode Schottky. This looks nice. And apparently I want to get rid of the stock. So here we have a Schottky diode in a huge package. I hope it still fits here. And again, this is just a proof of concept. If it works, it's good enough, but in the end, I'll need to use another part. Although it depends on the price though. If it costs, damn it. I just have to find a chip which has a current sense output. Okay, this is far too large. Now we have the opposite issue. Beep, 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 yeah, if you won't go off. Don't annoy me. Okay, that's one side. That's the other side. And we should be fine. Yeah. This could work. Let's try it out. So let's put 5 volt to see if there's a short. There is a short. It still draws 100 milliamp. So the current limiting isn't okay. The issue isn't the current limiting. So yeah, this is not a solution. I need to. I have no current sensing for now. This is so the 100 milliamp weren't going through here. There was another issue. This is because do I have to pull it up? The issue is that this point is low at the beginning. So if it is low, it's thinking that there is an overcurrent. And I think if there's an overcurrent, somehow this USB hub can't deal with it. And it puts, I don't know why, it burns 100 milliamp. I don't know, yeah, I don't know why, but it does. See, now it works correctly. That's the wrong USB. And it works correctly. Yep, so this is not a solution. It needs to be high at the beginning. So my two diodes here are not a good solution. I need to find another part. And yeah, well, I need yet another design, but it's almost ready. That's quite nice. Once I've changed this part, I'll probably also change this part, the switch, and not have a through-hole switch, but an SMD switch. So it's a bit easier to manufacture. But I need to find out which is still robust enough. Or maybe not a switch like this, but a switch which you rock, so you don't put stress on the sides. Or a press. Oh, that's not a bad idea. A push-pull, push-push configuration switch. That might be not bad. Push-push on surface mount might work correctly. Let's look for push-push. It's easier than switching. No, not push-push. Problem is push-push is you don't know in which state it is, so you don't know if it's overcurrent or if it's because it's off. When there's a switch, you exactly know which position it is. I don't know yet which one I want. Yeah, so I need to find another part, but at least we debugged it. We don't have overcurrent sensing, but everything else works. And we have overcurrent protection. It's just not sensing. Can I find a way where this might work? A budge, something like that. No, it's the same. At the beginning it needs to be high. No, there's nothing which tells if there's overcurrent. I need to find out from this one if there's overcurrent. The fuse doesn't tell it. The fuse doesn't tell me if there's an overcurrent. This is the last resort. This tells me if there's overcurrent. And just by probing here, I don't know if it's an overcurrent or if it just didn't have enough charge at the beginning. $10K inline? No. Yeah, let's just find the correct chip. So that's it for the stream. We've debugged it. I need to find something more, but I'll do that offline. Going through data sheets is probably not fun to watch on a stream, even if no one is watching. But I'll tell you once I've did yet another design. Until then, enjoy.